Hello, everyone, and thank you very much for the introduction. It's a great pleasure to be here among two very distinguished researchers in the area of artificial intelligence and blockchain. And I think we'll have a very interesting discussion today, especially because these two topics, we see them on the news, we read about them in literature, but it's not very often that we come onto a bridge that puts these two topics to work together. So we have Ian and Kostas here today with us to discuss their latest work and what are the implications for both the artificial intelligence and the machine learning fields, but also blockchain. So Kostas, could you tell us a little bit more about the paper that you've written? What has it proven and what does it show?
Okay. It's about artificial intelligence, for a lack of a better term, because of the fact, it is not really intelligence. It is, in fact, programming that does computational job, and that term is not very accurate, in my humble opinion. So we have a set of programs that we call AIs, AI agents, to be more specific, that we can load up onto the blockchain and basically do machine learning with the data that is stored on the blockchain. Because of the fact that artificial intelligence is very, very accurate at what it is being programmed to do, it is very easy to be weaponized. So imagine that all of the accomplishments that we have in the field of data learning and data science and AI so far, it is controlled by very few players, among them most of them, I think, IBM, Google, Facebook, Amazon, and so forth. Every big company out there owns one of them. So the thing is that having such a powerful machine working for one entity, whether that would be a country, an individual, or a company, is a very, very big burden for everybody else. So I'm not talking about specific AI agents, but for the total lot of them when they exist in synergy. Because what we're talking about in our paper is basically the notion of AGI, on how we can produce an artificial general intelligence, which basically is a set of AI agents that work in synergy in order to produce computational results that vary in various topics. So you don't have really one AI agent to predict the weather for you. You have an AI agent that can drive you from one place to another, check the weather, check the traffic, and so forth. So if you extrapolate this into the fields of medicine, into the fields of military, then it will be very, very easy to be weaponized. Another topic that we touch in that paper is how you can ensure that the data will be correct. That means that we will store true data within the blockchain, which is a topic we will be discussing today. How we incentivize the user by using the blockchain to store data inside that it is actually true, because that's the essence of it. If you have a true data set, we now have very, very big data within the internet. And the big burden is that we need to clarify which is lie and which is true. Within the blockchain, storing data on the blockchain will be something that you will be needing to pay for. That means that you will need to spend some tokens. So while you will be doing that, you are spending money. So you cannot really post lies or false information. Another great fact is also that we will be having the true auditing machine. And basically, it's about all this and what can we do with that.
All right, that's a lot of things in one question. So let's start to drill a bit deeper into each individual point, and try to see how this could benefit either the blockchain ecosystem or the world at large. So let's start with a very basic question, Kostas. Why should we put an artificial intelligence entity on the blockchain? What are the benefits that we can reap from that, as from a business perspective and from a user perspective and from a more public perspective?
Okay, say that you have a very powerful AI that is controlled by one entity, by one company. That would put you in the very difficult position that you will have to entrust your private data to that company, and you need to get their permission. If that AI agent or AGI is stored inside the blockchain, then it will be directly accessible by everybody, everywhere in the world, as long as they have some tokens to spend, of course. In the long run, this has many consequences. That means that in the long run, what we are actually seeing is that the power of tokenization shifts from what we call cryptocurrency right now to information and value. So that's another very big topic that we could discuss today. Another very, very important aspect is data encryption, because you can share your personal data, whether that would be medical exams or whatever, that would be used in order to perform deep learning inside the blockchain. You can encrypt your data within your own key, with your own key, and nobody else will have the permission to look at it or direct those data to their owner. That means that you will have the best privacy you could have in order to get your data inside an AI deep learning process.
Great, that's great.
That's about it.
So,
yeah.
Ian, your take on this aspect of the neutrality of an artificial intelligence on the blockchain, and how could you see that we would avoid the weaponization of these artificial intelligence against the users or against the data providers, essentially? What's your take on this?
Sure, yes. It should be obvious that any large corporation that's running a very large AI setup is going to outcompete anything on the blockchain. So we can't compete, if you like, using raw power, but we can compete using the quality of the data. The notion here is that if we can improve the quality of the data on the blockchain, then you can get to a point where people working with poor sets of data, which are, for example, internal opinions, internal data sets, and so forth, are actually working from a much worse source. They're basically feeding garbage into their AI, and therefore they're not getting the results that they could do. If we can improve the data on the blockchain by attaching, for example, identity information, dispute resolution provisions, payment provisions, as Kostas mentioned, and various other mechanisms, then we can get to the point where the blockchain data itself becomes the source of truth. If it's not on the blockchain, it's not actually useful, it's not actually relevant because it's not up to standard. We might as well work with the key data that's there. The second thing that happens is that if we manage to reach the fulfillment of this dream, we manage to build the AI onto the blockchain, it can prefer the data that's on the blockchain, and simply put, it can produce outputs which are, if you like, certified by the blockchain. So not only is the data, the starting position, now certified by information on the blockchain using normal Oracle processors and identity and so forth, the processing is also certified. The output that comes out is certified as to be the best of breed. And in this way, we approach the problem as a quality issue. If people are going to rely on data being produced by a large AI, then they've got a choice. They can go to a competitive big player that's able to marshal lots of processing resource, or they can go to the free, fair, open access blockchain and get a certified result. And this feeds into their own personal risk assessment.
So from what you're describing, it harkens back to some of the discussions that we've had in the early blockchain space about 10 years ago, where we discussed that an open ledger-based payment system would probably be better and more cost-effective than most existing payment systems, and even before that, to the structure and the nature of the internet itself, where an open interconnected platform for communication would be better than individual siloed intranets. So in this sense, do you see this as a rational continuation of the same discussion that started 30 years ago, essentially?
Oh, it definitely is. But it's very difficult to predict how it will pan out. I mean, we all, people in favor of blockchain money, Bitcoin and so forth, were very definitely proposing that Bitcoin would be a payment system. Now we fast forward 10 years since the beginning, and all those debates have been had, and what we've got is, yes, we have the ability to do payments, but the monetary value is the value of the coin is very volatile. So we're halfway there. We're not all the way there. What we've got is a hybrid mechanism from what we predicted. So how this will work out in the future is very, very difficult to determine without actually trying it at scale and seeing what actually bites us.
Absolutely. We'll touch upon this a little bit later down the discussion, but as you say, to manage to create a vibrant ecosystem that's self-reinforcing as a mechanism, it needs to have the appropriate incentives, and those would be incentives from users to be able to participate, incentives towards business, they want profit, and incentives towards governments or anyone else who is regulating or looking over these activities. So let's start from Ian on this. What's your take? Do we have the right incentives in place, or do we need to structure other systems to make sure that they exist?
Well, some of the experiments that are being done are getting towards that area. If you set up, for example, an open market for, say, weather data, then you allow people to download this data once it's on the blockchain. And those people who need it can also pay for it a little bit. We're talking micropayments, very small amounts of money. But slowly we get to the point where a large section, or if you like, a narrow but large section of data starts to pour onto the blockchain on a daily and minutely basis. And then that becomes reliable in the sense that as time goes on, that's the go-to place to get that data. So from an individual perspective, you want to get paid for putting that data up, and you want to pay to be able to use that data in some sort of reliable fashion, which is something where we need to do small baby steps in order to build up that marketplace, because at the moment, of course, you're competing with the open web for a lot of very low quality data. You need to move to the point where you're dealing with higher quality data, which is going to require a certain degree of institutionalization and economy and various things emerging.
I see. That makes perfect sense. So, Kostas, from your perspective, in a blockchain ecosystem where we have competing artificial intelligences fighting for supremacy among each other or specializing on different tasks, how do you see the incentive structures shaping around there? Would they fight with them between them for resources? Would they market themselves? How do you see this playing out?
Okay, basically we're talking about a biological representation system. So these systems are very, very well studied up to now. It's the definition of a Moran process, which is essentially when you have two or more mutants that fight with each other, only one survives and finally prevails over the others. In my opinion, competition within those AI agents will provide with more power the end users. We already saw that in data science with GANs, generative adversarial networks, which basically the two neural networks that are competing with each other so that they have the ability to produce the best result. So, in my opinion, it's not about the AI agent construction, but all about the data that is being stored inside the blockchain. So if you have many blockchains and the same neural networks, then the blockchain which has the most legit data will be the one that will be stronger in the long term. You need to imagine this like a compression of a very big amount of data by running that data through the convolutional neural network or the RNN or whatever. You basically compress that knowledge. You compress that knowledge, and the framework then knows how to tell what that knowledge is and be able to produce computational results. So it's all about the quality of data, not about the construction of the neural net.
Great. I think that's clear enough by now. But what I wanted to explore a little bit further on is the source of this data is probably going to be everyday people, like the activities, the movements, the financial transactions, the habits, all the behavior translated into economic value, essentially. And the model we've faced so far from Google and Facebook and the other services is that we provide you free service so that we can take this data from you for free, essentially. And we know that there's multiple challenges with this. So I'd like us to explore this aspect of the equation a little bit, so, namely privacy. And if there's hope that with the new methodologies and blockchain, we can essentially give some privacy back to the users, essentially. So let's start to dive a little bit on this. Kostas, you can start if you want.
Okay, so I strongly disagree with the current model of utilizing the so-called free information from all the big companies. Basically, there's an aphorism about it, and I will repeat it because I find it very, very accurate. When you don't pay for something, you are the product. So you need to digest this in order to understand why it is important for the quality of the data that is being provided and that you have the ability to dive into and ask information about it. You need to pay a little amount for that. We're not talking about big money here. I want this to be very clear, but we are talking about quality information. Right now, you can see that what we do have is a very large amount of data that make no sense. You cannot really utilize the data from Twitter, let's say. I'm sure that you have read into the newspapers about the AI that has been using the data from Twitter posts, and it became racist or Nazist or whatever. Mm-hmm. So the thing is that if you think about it in the long run, what you actually not paying is your ability to keep reading all this false information, all this garbage, let's say. It's garbage in, garbage out, like Ian said a little bit earlier. So we need to imagine what will happen in the next phase of information technology. And I very much think that blockchain is the perfect ground to build this up. I would define it as the future internet. We like to call it metanet right now, from meta, which is after, and net from the internet. Of course,
All right.
this cannot be achieved, very easily. You need great infrastructure. It can only exist within the infrastructure of data centers. It's not easy, but the idea is already there, is already out there.
Great. Ian, would you want to dive a little bit on the challenges that we're facing around privacy and new ways to manage this information?
Sure, indeed. There's two aspects here which are going to come to the forefront over time, I think. The first is that the data that we put onto the blockchain is generally public in the default condition. However, there are a bunch of emerging encryption techniques that we can use to hide that data in plain sight, if you like. One of these is differential privacy, another is homomorphic encryption. There's an array of things that we can do here, but what they essentially allow us to do is to put in place the data on the blockchain that we would want to use and have them accessible under various conditions, including commercial conditions, such that other companies could get involved in using them, etc., etc. The most exciting of those is homomorphic encryption, where we can put the data into an agent on the blockchain and then have the processing also be done by that same agent or an agent next door to it, such that the processing occurs transparently, but we cannot see the actual workings of that processing. So we can have the situation where we have, if you like, opaque or black boxed objects on the blockchain which do their work, they hide their data, we can contribute new data to them, we can ask questions of them, but what's happening inside is completely invisible to us, in theory. So this is one way forward. The second thing that we have to kind of get away from the technical aspects of this is that the privacy problem really is a social problem. The technology cannot do very much in the situation of society today when you've got, for example, large corporations that can aggregate a lot of data, which they will be able to do on the blockchain, and then sell that data for some standard revenue stream. Even if they start out doing this with the best of intentions and a nice contract and a loyal user base, we've seen in the past every one of these companies then sits on the top of the slippery slope. It starts to make a few changes and eventually it's sliding all the way down to abusing the data and abusing its users until it gets taken over by a newcomer or something like that. We've seen this so many times in the past that it's pretty much a law. The only way around this that I know of is to move away from the notion of pure commerciality, the notion of capitalist-style corporations managing and controlling the data, and instead move to a situation of cooperative groups such that we all sit together and we start a cooperative simply for the purpose of managing our data or some other task as well, perhaps. And inside the cooperative, we agree that we will benefit from that, at which point we are no longer we are no longer a misaligned group of stakeholders. We're no longer beholden. We're no longer losing out our profits to some random bunch of shareholders. We are the shareholders, and therefore we are entirely responsible for the entire cycle of the data as it goes onto the blockchain, as it comes out of the blockchain, and we get all the profits as well. So we can individually, as groups, set the dial as to where we want the privacy to be and where we want the profits to be, which is something you cannot do with the standard shareholder corporate mechanism. So I think that's what's going to happen. You can kind of see a vision of that with, for example, mining pools. Fairly early on in the process of mining, it became clear that it had to break up and turn into a different fashion. People would employ their own mining hardware, but it was too hard to work out the entire process, so they aggregated that mining into specialist pools. Now, if you took those pools and you called them cooperatives, you would have exactly the mechanism needed to be able to preserve privacy on the blockchain.
All right. A follow-up question to that, which is said by something you instigated. So we know that in cryptography and in the blockchain space that most secure algorithms or cryptographic functions have a certain expiry date. So it's not about when they will be broken. It's not about if. It's about when. Essentially, they will be broken. So, does this to you imply a sense of a different form of freedom of information regarding the data that is stored on the blockchain, regarding the past and the history of our civilization as we move into the next 50 years? Some of these will be expected to change and update, but I assume that the whole past at some point will become transparent, whether that's personal privacy or corporate privacy or more generalized. Do you have any thoughts on that?
Yes, many. Cryptographic algorithms are they're odd beasts. They're not particularly reliable in the sense of being able to predict what happens. Generally, within the domain, and especially with certain classes of algorithms such as hashes, we can be very, very sure as to how long they're going to last. Most hashes are still good today, even some of the ones that are being deprecated, because they're losing a particular function. But when you get to more exotic algorithms, and especially we start to talk about things like quantum encryption, quantum cryptography, the homomorphic encryption, and so forth, all of these are, if you like, brittle in the sense that we're waiting, we're praying that there isn't a serious break in their concept from the cryptographers. And the second problem that occurs with these is that the more complex they get, the harder they are to implement. So although we can kind of generally predict when a certain algorithm runs past its use date, we have the wild card that's sitting there that says, at some point it could just collapse completely. And for any individual user, for any individual system, they can make a mistake in implementation, they can muck up their keys, they can do any number of 100 things, and suddenly it's all available there in the open. So it's very difficult to come up with a conclusion that cryptography is reliably going to open up the history of the world in 30 years, which is something we saw with, for example, the NSA. They added elliptic curve cryptography to their Suite B list of acceptable algorithms, and then quantum cryptography, quantum came along and said, well, actually, we might be able to break this. The question then arises, can we break it in, say, 30 years? And the answer is, we don't know. So the NSA had to back away and say, okay, let's go back to adding in the old algorithms so that at least we have a choice. We don't know what the answer is, but we now need to be double safe.
Exactly. So my take on this, if I might jump in just for a second, is that while in all of human history we have a past that has the tendency to get deleted, essentially. History likes to forget things. History, people die, the books are destroyed, buildings are destroyed, governments fall and rise. And that was the paradigm so far, but I'm wondering if we're entering an age where instead of forgetfulness as the bottom of all data, we have full transparency and full accessibility towards everything. So a perfect historical trail. The more further up we move towards history. What do you think about this, Kostas?
Well, the data so far in historical data is based on physical means. It's the first time that we, I think it was the last 35, 40 years that we started storing data in computer files and magnetic tapes and so forth. So basically, what we are looking at is a new set of storing, a new way of storing data. So, blockchain is immutable in the sense that all the data that it's been contains in multiple copies, right? So you have every node within the network containing the same data. So it's virtually and theoretically impossible for the data to be lost. So this is one thing. The second thing is that this data contain pseudonymity. I would like to stay here a bit because people are misled and think that blockchain is anonymous. Basically, it's not. It's pseudonymous as long as you are doing transactions with a friend of yours over the internet and both of you are happy about the transaction. If you are not and one of you starts a dispute, then we are looking at both of these persons that were collaborating so far to do this transaction, and we are trying to find who is wrong and who is right. And this is a job for the courts. This will end up in a court. So I would like to stay a little bit here because of the fact that it is in the nature of people to do what they are what they think it is best for them. We do what is our best interest. So it is impossible to do malice if you know that in the medium that you transact, there is a very high probability, and it's no probability, it's a certainty that somebody will find out. So that's a representation of Plato's ring of Gyges. Basically, it was a myth that described what a person that could be invisible could do when nobody sees him. And this is exactly the reverse. That means that when you know that you are being watched, it is impossible to do something wrong because you will be caught. So in the long run, we are talking about a truth machine. And this is very important, both for the data that we have stored, but also for the long-term integrity of the data that will be stored as historical data. So I want to also stay a little bit in the subject that Ian has mentioned before about differential privacy. This is a very, very nice method. It's an old one, it's an old idea, introduced by Cynthia Dwork in 2006. I think that blockchain has all the ingredients that we need in order to construct such a machine that will be able to learn from data that are also private. So that opens up a very big field in bioinformatics, for instance. You can upload your medical data. If you want to be anonymous, then you will be anonymous, technically and really anonymous. And the AI agent that will be stored inside the blockchain will be able to use that data and learn from it. So right now, all the data scientists around the world are consuming time into NLP, natural language processing. You know why is that? Because it's easy. You don't have to get GDPR for data that has to do with how to read from a written paper, or read if that letter is an A or B or C. With medical data, this is an entirely different story, and we need a solution for that. So blockchain right now has the ability to store big blocks, big data, but we are not already there. We are close to that era that we will be able to upload our whole genome, if you prefer, inside the blockchain. And nobody will be able to pinpoint who that data belongs to whom it belongs to. So that will open a very big door into actually find the cure for many genetic diseases. Maybe even cure aging. Who knows?
Yeah, this brings me a little bit back to some of the very basic reasons why all three of us are in the blockchain space, essentially, and some of the work that Ian has pioneered around triple entry accounting, and the fact that throughout human history we have had ledgers, and we've had methods of writing down information and correlating it with others, with partners, trade partners, business partners. And usually that ledger had a watcher, right? Whichever system that we have, either political or financial or economical, you always had someone to watch over. And one of the reasons I feel that we're all in this space is that the blockchain gave us a glimpse in a system where the watcher and who watches the watcher, which is, you know, the eternal question around these systems, is the answer to this is simply everyone. Everyone can watch, and everyone can have a trace back of information that is or acts or evidence against anyone who has perpetrated a bad thing against this system. And so with that in mind, I want us to move towards the final questions, which essentially center around the magnitude of all these things that you've talked until so far, and how do we make a system that can manage all this data? How do we make a system that has the infrastructure to be able to process the history of humanity and fuel it into an artificial intelligence and feed back to us useful data? Just a few days ago, we saw that Ethereum, for instance, it started choking, and the transaction fees started going through the roof just with 1 million transactions a day. How do we build a system? Is the blockchain the best place for this? Do we have any blockchains that actually work with an efficient manner? What do you guys think? Let's start with Ian.
Thanks for that curveball. There are multiple ways to scale up a blockchain. And I don't particularly want to get into naming names, but big blocks have clearly been shown to work. The possibilities of replacing proof of work with proof of stake and delegated proof of stake and so forth have been shown to work, at least assuming certain assumptions. So it's certainly possible to get the transaction flow up to thousands today, thousands of transactions per second. Tomorrow we can go to tens of thousands, 100,000, and so forth. The technologies are there to be able to do this. You have to balance your assumptions as to what it is you're going to accept. So I don't see a problem in the future putting vast numbers of transactions on blockchains. And of course, we know that we can also have vast numbers of different blockchains, so we can cross.
Great, but in this specific case, if we're looking for interoperability and the largest possible pool of verified data, do you think that there's space for multiple blockchains, or do you think that network effects are going to cause a coalescence into one blockchain to rule them all, essentially?
Oh, I think there'll always be multiple blockchains. There will be, of course, a dominant blockchain, but that's the nature of things. As we move forward, the key thing about the data is that it operates to some sort of standard, such that when you place that data onto a blockchain, that piece of data is sitting in a packet somewhere, whether it be a UTXO or a message that's gone into one of the message-based systems, or it's a smart contract that's sitting on something like Ethereum. That can still be picked out of the context of the blockchain, and it can be treated as a signed piece of data in and of itself. The signature is the blockchain, if you like, even if there isn't an explicit one. So once you get a situation where you've got multiple different blockchains and they have managed to, if you like, create their niche of a particular form of data, and you want to start melding those across the two different blockchains or the multiple blockchains, it's a matter of just pulling the data out and using the authority of each blockchain to keep that data consistent. So I don't see that as a problem.
Mm-hmm. All right, I see. Kostas, would you like to give us a few comments on the scalability and infrastructure that all this construct could be looking at going forward?
Well, I explained a little bit earlier that this is basically a Moran process. That means that the most prominent blockchain will probably be the most dominant. So I agree with Ian on that. Right now in Ethereum, for instance, which was the first platform of blockchain that we saw basically smart contracts to start happening a while ago, all of the programmers there have the same problem. The memory cost is very high. So the gas really limits tasks like deep learning, for instance. We have discussed with two scientists that they did their project on IMDb titles. They did that because of the fact that IMDb titles was text, and they were able to do deep learning into their perceptron, their neural network, within very few amount of money. Because if they wanted to do something more complex, like let's say this deep learning into images or what, but they could not because Ethereum was a very expensive platform to do so. So in my humble opinion, you need two basic things. The first one is big blocks, and the second one, you need very low fees for the transactions. There are a couple of blockchains right now in the field, which is BCH and BSV, which are forks of the BTC that happened 2 years ago. Those are very interesting platforms, and if you want to do deep learning and store AIs on that. Not that EOS or Ethereum is not capable of doing something like that, but in my humble opinion, you need to have these very important ingredients in order to have something like an AGI tomorrow.
And for everyone else listening, I would like to point you back to the paper of Kostas and Ian, where the actual proof of concept took place, and where we have there is some data around which blockchain would be more ideal for this future application. So as we're coming towards the close of this conversation, I'd like to open the floor essentially to both of you and try to get your opinions on the more practical side of things. So if you could describe to me a successful business story or some business continuity that you can imagine where we could combine these two elements we've been covering together, so artificial intelligence and blockchain. Let's start with Ian.
Sure. I think the headline interesting use case that's going to happen here is pure transaction flow. And by this, I mean, if you have a bunch of cooperating companies working together in a particular supply chain context, what they're going to be doing is trading amongst themselves. But each of those trades will have a lot of different events circulating through each particular trade. You have, for example, acceptance, offer and acceptance. You have deposits being made. You have delivery notes being created. You have performance milestones being done, an invoice being generated, payments being done, outages and errors and so forth. All of these things can be coded up as a series of events in a complex state machine that creates a fact onto the blockchain for each one of these events. Now, these are very interesting events because they're unlike the events that exist in a normal accounting system inside a company. Inside a company, what happens is the accounting is basically just a view on reality, because it's an opinion made by the person, which is the same as the company, and therefore the person is actually biased to change the numbers, etc., etc. But in the context of putting it onto the blockchain, we have a different situation. The event is actually authorized, or it's stamped by both parties, the recipient and the sender. So you get this situation where you've got two parties to a trade, and they've both agreed to each event, and the next event, and the next event, and the next event. So you have this series of, if you like, self-proving events which go through the blockchain. Now, we call this triple entry because each party holds one of these events, and the blockchain is a third party that holds the events. Now, once you do this, what you've got is a series of facts. These are now the reality. They are the foundation of a new generation of accounting. Because the parties have already agreed, they're not going to back out of that agreement, even if there's some minor errors. They will accept that these are the facts. We've now got reality on the blockchain, and accounting will be built on reality as opposed to being built on the opinions created internally. Now, what this leads to is the ability to automate large parts of the invoicing cycle. And once you do that, you can also turn around and audit in the same event, which is to say you can get real-time auditing. Every event that occurs can be audited in the instant that it occurs. And you can do this in code. You could do this in a state machine inside the blockchain. You could even do it under homomorphic encryption such that the auditing that is done is opaque, is invisible to everybody else, but it comes out with this result that says, yes, that's a clean audited transaction. And if you move forward and start thinking about that, once you have now set up the audit process to be automated and on the blockchain, what's the next thing to think about? Well, taxation. The tax people are going to be looking at this and saying, well, you've obviously audited everything precisely as it happens. Why can't we just carve out the tax payments that occur or the fees that occur to third parties or whatever it is and do that in the same process? And we're now getting to the point where we are now incorporating, if you like, real-time taxation into the invoicing flow, which, of course, nobody particularly likes taxation. But if it works, what's happening now is you've actually solved your headache. You don't have a headache anymore because the whole thing is done perfectly audited, perfectly to the rules, perfectly to the code, and it's all over. You no longer have this end-of-year drama of having to prepare tax reports and so forth. It's already been done on the blockchain. Now, this raises a lot of questions. Obviously, the tax people and the audit people and so forth are going to be piling all over this and saying, my God, what are we going to do? You know, is this good? Is this bad? Everybody's going to have an opinion on this. So it needs to emerge slowly, bit by bit, and it will emerge slowly because what will happen is groups of companies will find some small piece of data from which to start. So you get these green shoots gradually stepping little bit by little bit towards the ultimate goal of having an entire supply chain being perfectly audited and perfectly taxed.
I think I understand what you're discussing, and beyond taxation and beyond auditing, it would have profound implications towards corporate governance as well, which is an area that needs work globally, not just in the EU or in the US. And to me personally, what you're saying resonates on a very deep level because it also implies a sense of reciprocity between the taxation agent on one hand and the taxable entity on the other hand. So instead of this being just a linear relationship, now the person paying the taxes can look back into the money that he paid and essentially follow that trail around to see where it ended up, which brings some very interesting political and socioeconomic implications. But let's get a closing statement from you, Kostas, on the practical aspects of artificial intelligence and blockchain, and where do you see the biggest benefit for the industry in the next while?
Okay. I would like to remind you about a 100-years-old theory from Kurt Gödel, which is the incompleteness theorem. Basically, what it states is that no theory can be self-contained and be at the same time complete. Mathematics, for instance, can have problems that cannot be solved through mathematics, so you need to insert a new set of axioms in order to expand mathematics and solve this problem. We've seen this happening with Riemannian geometry and Euclidean geometry. We've seen this happening with all scientific fields and computer science. And now we are going to see that with artificial intelligence. Artificial intelligence is the new set of axioms for every scientific field out there. And I strongly suggest that maybe blockchain is another set of axioms. That means that we do have two, as I like to call it, two Gödel expansions that will probably be the vehicle for humanity to go a step further and not stop where it stands right now. We probably will see that within the next decade. I don't like to make predictions because we are looking at an exponential curve that will soon may turn super exponential. So we may be a few years or a few decades away from that, but I assure you this will happen.
All right. And let me drag you back to the practical aspects of it, though. I think I understand this theory, and it's fascinating, but it's a little bit more philosophical than what I was aiming for. So let's talk a little bit more about the point that you brought up about the human genome and blockchain and artificial intelligence. Or is that too secret to talk about right now?
Well, that is only a use case for now. I think that every deep data scientist will have to look into this kind of information handling, let's call it, inside the blockchain. Supply chains like a big city or a big company will probably benefit from something like that. Maybe a whole country will benefit from something like that if they decide to incorporate blockchain and AI within their infrastructure. Imagine a big city that will be able to predict how many garbage will it be able to produce the next day. Imagine to have the ability to predict with high accuracy what is the power they will consume the next day. So it all boils down to a more green society, more economic for the world. This is why I expressed my philosophical aspects just a little bit earlier. In my humble opinion, there will be no field that will not be benefited from something like that.
I'm pretty sure. I just want to resonate back with the many hundreds, if not thousands, of people who are listening to us right now and are building businesses or run enterprises, and they want to have a slightly firmer grasp on how that future would look, so that they build it for everyone to use, essentially. And to this end, I want to bring up some of the old examples that we used to use in the blockchain space of what may happen. And one of the things we talked a lot about was the Internet of Things. We talked about smart locks, we talked about self-driving cars, asking for priority in a specific lane and doing microtransactions to anyone that was ahead of them, so they may veer out of the way and they can move faster. But now we can take this into another level. We can essentially use this micro monetization between the data producers, which is going to be us, it's going to be our machines, it's going to be our locks, our washing machines, everything, and to the processors of this data, or the artificial intelligence itself, if it has the ability to do monetary transactions. And that will flow through economically towards those who buy the actual data or the results from the artificial intelligence. Those that survive, at least, as you said, right? Because they will be competing each other. They will be competing with each other on who is the most fit for a specific task. And we'll see some deal only with natural language processing. Some will focus more on image recognition. Some may focus more on gaming, and some may focus more on auditing, on the other hand. But what I see from a business perspective, which is very interesting for me, is how all this ties to the concept of micro-monetization. And it's something that we've been talking about in the blockchain space for the last 10 years, but we haven't really seen it in practice. So with that, I want to get your closing remarks so we can wrap up this conversation.
Shall I go?
Yeah, Ian, please.
Yes. So clearly that's a wonderful dream, but there are too many moving parts for any group or industry to be able to put them into play at the same time. So you need to start from somewhere and then build on some very small foundation and inch your way up the chimney. And the way I see this happening is you need to look at the transaction flow that various industry sectors start to put onto the blockchain for communication purposes. And I would particularly look at things like supply chain and so forth. It will not happen in, if you like, an industrialized or institutionalized fashion. It'll start out by some small group just shoving something on the blockchain and then discovering somebody else accidentally thinks, oh, that's good, I can use that. And then they start to cooperate. It's going to happen from the grassroots. And until you get lots and lots of this data moving back and forth on the blockchain, you're not going to see the next level, which is to start doing the micropayments, trading the processing, starting to compare information and compete for information and so forth. You have to have a base. You have to have something that's moving before you can start to build.
Absolutely, great. Thank you for that, Ian. Kostas, one closing remark from you?
Well, yes, I believe that this technology is the vehicle to the future. I agree with Ian. We are at the very, very beginning of that, even if 10 years has passed since the introduction of blockchain and Bitcoin. We will see how it goes. I am very optimistic.
I'm as optimistic as you are on this, and I think that's one of the reasons we're still in this industry and not moved further on by today. So, gentlemen, I'd like to thank you for a great discussion today. I'm pretty sure there's anyone watching will have questions, and I hope we're there to answer those. But if not, feel free to research, because this is going to be a big part of humanity's future, and we need to start investing in it intellectually, at least from today. So with that said, thank you very much and have a great day.
Thank you.